Good evening, all. Namaste, Harsh. Good evening, Ruchita, Sriram, Rohit, Vivek. Right. We studied all those things. What happens to it? You need not remember them, but you can. The knowledge you gain will not go anywhere. Later, tomorrow you go for embedded system or anything. Okay, it will be there. So they made Sonali instead of that. They introduced this computer organization for electrical people. So like that, they modified it. It is just a copy paste of what is that CSC syllabus of computer organization. We can see those questions for understanding. Okay, so let's finish these two. Then I may take CO separately for EC people later. We can see that. Don't worry about it. Now in ESC it is not removed. At least in ESC it is there. Or you write local exams. Exam point of view it is there. Okay. And another thing I want to say is. At any time during my first class or last class or any class, I always say only one thing. Okay, don't study only for exam. This knowledge will not go anywhere. Where's refreshed, refreshing? Okay, refresh over. Okay, we are back. So don't worry much about those things. So 2 days we are having. Okay, see you observe today and today in the afternoon I have uploaded all DPPs in the group. All DPPs in the group of microprocessor. Immediately microprocessor is here. Okay. You know another joke. Today morning, I got one message from one student in Facebook. Please listen. This is what we call really fun. Okay. Today morning itself, he messaged me in Facebook. Sir, I want microprocessor notes. I want it like anything, sir. We immediately, please, sir, give me, sir. He messaged me in the morning. So I said some modifications are to be done in the notes. Some mistakes are there. I will correct it and I will give you in the evening. Okay, sir, no problem. I will wait. So he messaged me in WhatsApp after that. Okay, I will wait up to evening, no problem. So now evening he don't ask it again. So things has changed completely. Right. So whatever you learn will not go anything anywhere. Okay, wherever whichever exam comes on micro will be there in your ESC etc. Or in your future also it will help. Don't worry. So 2 days we have we'll finish whatever the way we discuss same way. Let us finish it. Okay. What is that lemon? Yes, other exams you will get it. Lemon can be in the vehicle tire also. Finally, lemon must be squeezed. Right. So let's move. Good. So let's move. Where we are. SRAM DRAM is there in your syllabus. Tomorrow we are going to complete it. SRAM DRAM. Don't worry, Ganesh. Okay. There's clearly specified also this time. Okay. So what are our leftover? Okay. क्या हुआ अनुज? See here, all your queries. I am taking one special class on 9:45. You can attend there. We can talk about the new notification if you want. Notification mein what is there? What is there? Confusion kuch hai, whatever. Yeah, today 9:45. After our class, I take some 15-20 minutes this session and we can talk there. So I think you are the culprit, right, Aditya? Because of you, this is happening. Yes, Ganesh. Morning, most people, even it is at 7 o'clock, they are coming. I am very happy for that. Multiple set questions I liked. There are some questions where you have multiple answers. Okay, so let's start the story. So, what are the leftover instructions? Yesterday we have discussed EI, DI, RIM, SIM, NOP, ALT. Okay, EI, CI, DI, HI, whatever, these are the leftover instructions. These are called क्या lag तो नहीं आएगा deep machine control group of instructions. Machine control group of instructions. So I observe one thing is in an academy, whenever people take admission, I mean in our subscription, whenever they take it, first thing they do is they watch all classes at least 5-10 minutes. I think every lecture का class में 5 minutes, 10 minutes they will see, they will see, they will see. Then they waste some 5 or 6 hours of time. Every class में क्या हुआ, what's happening in this class, how he teaches, all these things come and go will happen. Okay. DPP admin group. You are not in the group. What happened here, Aditya? You are there from 1 month, 2 months, not yet, right? I'll add you, don't worry. Yeah, every day, first day, once they enter, that is the first thing everybody do. Every class, they will attempt for 5 few minutes. Okay, now, so listen here. Now, these are the group of instructions. Yes. But 5 minutes, how will you judge whether it is, suppose a particular person came to my class now itself. It is not a first class. Okay, it is some middle class with there is a link between this class and previous class. Or in this particular day, I'm just speaking something for last 8 minutes. I'm just killing the time, for example. So how can he judge? So at least should not watch the random lectures. Start from the first lecture, then it is good. Or ask your friends, that will be good. Yeah, most of the people decide by look. If the person looks young, they think what he teaches. If the person is not young, he look a little old, then they feel okay, he's very good teacher. This is the first impression you will get. Okay, so all these instructions are good, Nishta. Oh, thank you, Ganesh. See here, all these are 1 byte instructions. All these are 1 byte instructions. Okay, next. How many machine cycles are required? All these are one machine cycle only. That is opcode fetch, nothing else is required. Opcode fetch only. And how many T states is 4T? It is exception is 5T for halt instruction. Remaining all may 4T only. Then what is the addressing mode? Implicit or implied addressing mode. Very good. No flags affected. So this is the basic of all these instructions. Now what are these? One by one we will discuss. One by one we will discuss. Now the first one we are going to discuss is EI. What is EI, sir? EI means enable interrupt. Okay, so when 8085 executes this instruction, it enables the interrupt enable flip-flop of 8085. 8085 is having one flip-flop called interrupt enable. When E equal to 0, all flags, sorry, why all flags? All interrupts disabled except trap. Yes. When E equal to 1, all interrupts enabled. Okay, this is enable interrupt. Generally, please listen. When microprocessor executes any interrupt service routine, then what happens is it will disable the other interrupts. Why? Because the computer is not accepting nested interrupts. Nested interrupt is not available in 8085. So when any interrupt is recognized, then computer will disable the all interrupts by using this flip-flop called as interrupt enable flip-flop in the 8085. So when it becomes a 0, all interrupts will be disabled except trap. So to enable that, we should use the one instruction called EA. For example, interrupt has occurred. Computer will come to ISR. In the ISR, after your job is done, you should keep one instruction at the last. What is that? EI. What is EI? Last May, you should keep EI, which means that enable all the interrupts. My ISR is completed. Enable the remaining interrupts. So they can take their job. Okay, for that purpose, we use this instruction called enable interrupt. Next, if you have enable, you should have something else. What is that? Disable. Disable interrupt. I am very happy. I wrote 0 in both cases. What is that both cases here? Thank you. Okay. Thank you. Anuj. So I'm happy even they have removed this from your syllabus. You people attended my class. I feel very happy for that. You have been saying that, Asif? Where you are saying that? Let me check it. Oh, 1. I'm sorry. What's happening? Okay, fine. So shall we move? So disable interrupt. Disable interrupt means it will, whenever this instruction is executed, then I didn't thought that you don't attend. I thought you will attend, but I am happy for attending. Because you are my students, you are not only worrying about marks. I too love you all. Right. So whenever this instruction is executed, then interrupt enable flip-flop is equal to 0. That is, all interrupts are disabled except our friend. What is that? Trap. Thank you, Asif. Right. It's looking like going like a farewell class. No, tomorrow we have class and Monday onwards again we have networks class. Okay. So let's move. Or I may take revision class also again for your subjects lastly. So that quick revision we can make a plan in special classes or somewhere. So good. So now whenever there is this instruction is executed, then interrupt enable flip flop is equal to 0. That is all interrupts are disabled except trap. Here I want to give you one point is IE is equal to 0 under following three conditions. When your interrupt enable will be equal to 0, three conditions are there. What are they? First one, when disable interrupt is executed. Whenever DI instruction is executed, your interrupt enable flip flop will become 0. That is, interrupts will be disabled. Second case, when any interrupt is recognized, अगर कोई interrupt recognize हुआ तो any interrupt has occurred, then what happens? Then also to avoid the nested interrupt in 8085, when any interrupt is recognized, then interrupt enable flip flop will become 0. Why this is happening? To avoid what is that? Yes. To avoid nested interrupt. Last point. I forgot to tell you one thing. I may take one extra class somewhere. I will tell you. I will plan and such that in digital, what if I will cross check what they can ask with the new syllabus extra something is required, then I will take that part also. You don't worry about that. Whatever we discussed, everything is there. Whatever we discussed, that part is 100% is there. If extra is required, I will take it. Don't. Schematic trigger you study in analog, Nishita. Actually, this multi-vibrators, schematic trigger, all you study in your analog. Kamesh sir will teach you that. Okay. So now when any interrupt is recognized, to avoid the nested, this one. Another case is when reset in bar signal equal to 0. Okay. When reset in bar signal is equal to 0. Whenever reset bar signal is equal to 0, in that case also, okay, your interrupt enable flip flop will be 0. These three conditions, please remember. Okay, what are the three conditions? When DI is executed, when any interrupt is recognized, when computer reset button is pressed, then also your interrupt enable will be disabled. Now these two instructions are completed, so let's strike it. Only four more to go. So the 4 more may let us complete the simple part, NOP and halt, or halt we take last. Let's complete NOP. Then we discuss halt and RMSIM, then it will. Please show AI. Take it. See. It will enable. Nested का मतलब एक interrupt is running, one interrupt is running. बीच में एक और interrupt आएंगे तो computer will not respond. अगर एक interrupt is running, बीच में एक और interrupt आए तो computer is going there. बीच में एक और high priority आए तो computer is going there. This is called nested interrupt. एक interrupt का बीच में एक और interrupt आया. That is when it is running one interrupt. If some interrupt occurs in between, then computer deviates and go to the next interrupt if it is high priority. That is not allowed in 8085. Once one interrupt is serviced, during that period, it will not take any other interrupts. Whenever you reset the system, reset in bar pressed, that is whenever you reset the system, then also what happens? Whenever you reset the system, then also interrupts will be disabled initially. initially whenever you switch off the system or reset the system. Okay, this must be for 3 clocks. We discussed that in the reset conditions earlier. Okay, good. So now let me discuss NOP also. NOP का मतलब very simple. Not. It is NOP. Means no operation. कुछ काम नहीं. It will not do any operation. It will not do any operation. That is the meaning of no operation. NOP ka meaning is no operation. It will not do anything. Okay, but it will kill CPU time by 4 T states. It will kill CPU time by 4 T states. So you also will be in NOP state for so much of time, right? As Sura told. So when I went to this one of the interview, I think in UPSC long back, then they asked this question in interview: what is the meaning of NOP instruction? Where they will use? Where they will use? Let us understand the use of it. You tell me with your just basic common sense, think where it can be used. Some people told already it can be used for delay operations. Correct. So to delay the system operation, you can use it very good. Other than that, any other thing. To communicate, what is small operation? Yeah, to communicate with slower peripherals, we can use it. Okay, बीच में gap चाहिए तो you can use NOP. Another. Why delay, sir? One output to another output. Your system is giving output rapidly. You may not be able to read. So one output and another output के बीच में we give the gap. Any other where we can use NOP? Why interrupt service में why NOP है? Delay can be comes under clock or anything. NOP is delay means clock and all. Another thing. Ind is another other than these two. Program update. For example, in the program, you write NOP. Later you can remove this and write new instruction also. Okay, so sometimes you want to update the program. Okay, whole program need not be changed. Okay, whole program need not be modified. Some places may you can keep some NOPs. Okay, so those instructions can be removed later and you can insert something extra. In that case, no problem will come. So sometimes based on the critical conditions or points, they use some NOPs. Interrupt से बचने क्यों? Yeah, it may NOP itself waste only, but safety purpose we keep it. What do you mean by saving from interrupt, Rohit? See, the one machine cycle opcode which is 4 T states are required for what? NOP. The instruction has 3 main uses. It frequently used in delay loops. We'll also do it next maybe. It is also used to interface slower peripherals. It is used to remove or introduce any instruction in the program. Suppose हम एक कोड लिखा, कोड में एक इंस्ट्रक्शन इज रॉन्ग, यू कैन रिमूव, देन इस प्लेस में क्या रखना? NOP. Debugging. Okay, is it clear? अगर NOP का प्लेस में you can add something also, no problem. Okay, next. One minute. Okay, right. So remove NOP, keep whatever you want. That's all, Aditya. Yes, right. Okay. So no operation. So CPU will not do anything. Just opcode fetch complete. It will only do opcode fetch. Nothing it will do. That is the instruction. Okay. It will not do anything. Just opcode fetch and happily relax. Okay. 40 states will be just wasted. It has only opcode fetch. That's all. Nice. Suppose you want to generate, suppose simple computer, using computer, you want to generate this kind of waveform. What to do? You should wait the system for this much amount of time and make the 0. Again wait for this much amount and make it 1. So to generate this clock signal or triangular waveform, from one step to another step, there is a delay required. Okay. So to create that delay, we can use this NOP operation. We'll see that delay programs. So enable interrupt, disable interrupt is there. Then let me explain halt also. Then lastly, we discussed sim and rim together that can wind up your total instruction set. Then we can clap and make the noise. What is meaning of HALT? Halt. So stop the program. So whenever 8085 comes with halt, generally 8085 what it will do? इसका हो गया next, इसका हो गया like that. Continuously it reads opcode fetch, read it, opcode fetch, read it, like that. It continuously read. Whenever halt comes, computer will stop. It will do this job until what? Until halt comes. Halt comes. Okay, mera kaam to ho gaya. It will stop execution of the program. That is what is the meaning of halt instruction. We are saying computer because computer don't know when to stop now. We are saying computer with the help of this instruction called as halt instruction. So let me upload that halt instruction. I keep on teaching at 9 o'clock. You say time out, sir. This is a halt. So our computer also we should say. Yes, morning only I saw that video. Now I am understanding that. Ruko bhai. Okay. So listen here. It is a single byte instruction. Whenever this instruction is executed, the processor is stopped. Okay. Processor stopped means processor ka execution will be stopped. It stops fetching and executing of the instructions from the program memory. The address bus, data bus, control bus are tri-stated. Examiner can ask you this. Don't ask me in which exam. Right now I cannot say that. Okay. After halt instruction, your buses will be tri-stated. So this is what happens in the machine cycle. Okay. What is 3 or 4 letter instruction? I didn't understand, sir. Why, sir? Maximum instructions are 3 or 4 letter instruction. It is not 3 or 4 letter. It is a code. Computer don't know this. It is for us. Okay. Actually, it is for us. We are using this code HLT. Okay. The assembler which is there, whenever HLT comes, it will convert into this code. Okay. It is for us to understand it as halt. We use that mnemonic. Mnemonic means code HLT. We give it to assembler. Assembler will give the corresponding machine code. Computer will understand only this. Shortcut. Okay. We should not write to the computer move A to B. Shortcut kya? Move A comma B. Okay. So similarly, you should not write move immediately. This much you cannot type. MVIA. Less like nicknames. Why Sora? Why not full name of you? Okay. What do you mean by that, Asif? Voice activate myopy? Good. So see here, during the halt instruction, you have 40 states. For 3 state, my computer will understand it is a halt operation. So in the next cycle, what happens? In the next opcode fetch of machine cycle, okay. In the opcode fetch only, second machine cycle, what happens? It is A15 to A, it is copied with the program counter. Then it can understand that halt FF is found set. That is, halt is ready. Then what happens? Processor will enter into halt state. Processor will enter into halt state. Halt state means stop. Halt ka meaning kya? Stop. So that's why we say some people will say 4G state, some people will say 5T state. 5 also correct, 4 also correct, but first preference give it for 5T states only. I gave this here. Okay. So that is about your halt instruction. Okay, what is the meaning of halt instruction? Somebody told that Pupul, I think, Ruko bhai. Not all the, you don't run all the program at a time. We run only one program at a time. So computer is in a continuous process of reading. First day I told one flowchart, na, generate next address, read it, generate next address, read it. It is a continuous loop. So that loop will be breaked whenever halt comes. Okay, right, Harsh? Right. Now we left with only 2 instructions. Yes, we came to the day where you can finish your instructions. So the last 2 instructions, those are sum and rim. So not sum, sim and rim. So rim and sim. First we discuss sim. What is sim? Set, interrupt, mask. Rim sim. What is that? I think it's some song. I also listen somewhere. So let me what we call upload the slide for this sim instruction. Right. This is what the meaning of sim instruction. During, okay, please listen. Before sim instruction, accumulator must be loaded with this bit pattern. Before sim instruction, your accumulator who is having it, who is there, that should be loaded with this kind of bit pattern. Accumulator should be loaded with this kind of bit pattern. What is that bit pattern, sir? So accumulator में हम ये store करना चाहिए. What is that? What is the serial data you want to give? Serial output data you want to give, that should be loaded here. What is whether serial data enable or not? Output data, serial output data enable. What is SOD, SID pins are there? Na? These two are used for serial communication. So this is not used, not unidentified or not described by our manufacturer. It is R7.5. That is, it is used to reset 7.5. What is 7.5? RST 7.5. This is now see here. Why this set interrupt mask instruction is used to set or reset the interrupts. That is to mask the interrupts or unmask the interrupts. We use this instruction. For that, first one is MSC. What is the meaning of MSC? Is mask set enable. What is the meaning of MSC? Mask set enable. If this is 1, then only next 3 bits valid. Otherwise, we don't worry about the next 3 bits. Otherwise, we don't worry about the next 3 bits. See here, mask set enable must be 1. Okay, when mask set enable is equal to 1, then if it is 1, RST 7.5 will be masked. If it is 1, RST 6.5 will be masked. If it is 1, RST 5.5 will be masked. It will be difficult to visualize like this. So let's take one example. It will make our it will give you better clarity. So for example, write a program yeah 6.5, sorry for that. Write a program to give serial output equal to 1 and also mask 7.5 and 5.5 or mask otherwise we write like this. .5 and 5.5. I want to mask the interrupts 6.5, 5.5. I don't want to mask 7.5. Then what to do? First, okay. So here you want to give 1 because serial output is 1. Enable the serial data. Go back. You take this here anything, no problem. Reset is not required here. Mask set enable. You need to mask this. This is not masked. These to be masked. Is it clear? This is SOD. It is serial data enable. This is unused. This is R7.5. This is mask set enable. It is mask 7.5. It is mask 6.5. This is mask 5.5. So which will give you C and B hexadecimal. You can keep 1, nothing wrong. Generally unused we can keep here, nothing wrong. To avoid unnecessary things, we make it 0 generally. So see here, what to do? MVI, first you make this data, na, you load this into accumulator. Move immediately accumulator. These are used for serial communication. To send the serial data through computer, we use this serial output data. Then sim. So these 2 instructions will do this job. Now you understand, na? So this instruction can be used for serial data and also to mask interrupts. That's why set interrupt mask. Which interrupts are to be masked, that can be done with the help of this. Now I will show you this. Just to see this, in this any doubt, please ask. You should get one doubt. Positively, you should get one doubt. I think some people, where is that? You can mask that by using DI instruction. Ganesh and DI instruction is there, the disable interrupt, which will disable all interrupts. What is axis? Don't care. You keep anything here. Computer that 8085 manufacturer has used only 7 bits. He has not used the 8 bits. Yes. Why only R7.5 is the doubt you should get it. You don't get the proper answer, or even you read it also, you don't understand this answer from anywhere, most of the sources. But I will explain you. Don't worry. Okay, I analyze that I got the answer. I will explain you the same thing. So why R7.5 is only there? Why not R5.5 is there? Why R6.5 is not there? Why only R7.5 is there? I will explain you that. Okay, just wait. So for that, we should know the internal structure of 8085 interrupts. How this part is implemented by hardware. Let's see that also. How this instruction is implemented, how computer is handling the interrupts of 8085. Let us see. Let's see the hardware part of the 8085. Just 1 minute. Where is that? Yes, got it. One minute, please. I'm sorry. I'll upload this. Whether it is visible or not, please tell me. If it is not visible, I will upload again. It's not yet uploaded. Don't worry. I think it will upload. Good. So now see here. I think this is require more understanding. Okay, please listen here. This is how computer your interrupts are designed in your 8085. This is how interrupts are designed in 8085. Please listen here. Now I will show you properly. See, it is a D flip-flop with input is equal to 1. It is a D flip-flop with input equal to 1. So now see here, whenever trap occurs, I told you trap is both edge triggered and also level triggered. I hope you remember or not. So edge should occur, and it should remain 1 for some time. Then trap will give you the interrupt. Okay, when trap will give you interrupt. No restrictions, straight line, smooth line, no restrictions in this path. What is the vector location? You know it is 0024. Is it visible or shall I zoom it? Is it okay? Okay, good. V, no Z, only V, right. So now see here. You can clear this trap interrupt generally for the RST input and trap acknowledge. Okay, what is the meaning of trap acknowledge, sir? Whenever trap input is acknowledged, the system should not, trap input is acknowledged, the system should not take another trap. Okay, you understand that at that time this will be resetted so that system will not what we call respond for multiple times for a single interrupt. For example, see here, none. Okay, you can say nesting, or for example, trap has occurred like this. Trap has occurred like this. So what happens? Your queue will become one now. So then it will go to its vector location and it will doing this job. After completion, if still this is at one only, what is the problem? If still it is at one only, multiple traps will happen. Multiple traps will happen. So what happens is we reset this system. We reset the system by using trap acknowledge. Whenever trap acknowledge comes, it will reset the system. Once it is a trap acknowledge, then we reset it. Okay, even your input is at a trap only by chance, by default. Suppose, for example, it is a trap only, no problem. We reset. Okay, then what we expect is it should become 0 and again become 1. Then only next trap will be recognized. Is it clear? The trap has occurred, it is by chance. For example, somebody has pressed that trap and that switch is stuck at one only. It should not give multiple interrupts because it is a critical application, emergency application. So what they have designed, whenever trap acknowledge comes, immediately it will clear, so that only when it becomes 0 and next trap comes, then only system will respond. This is one thing. Now next lesson here. Okay, so next one is trap ka part ho gaya. Now come here. Here carefully observe. If mask set enable is 0, what happens? AND gate ka output is 0. Sorry, input is 0. You forget about the remaining 3 bits. Forget about the remaining 3 bits. What is the answer you get? 3 zeros आया. SR flip flop को 0 1 दिया. So everything you studied in digital is applied here. So it will be resetted. So 0 bar is 1. What is the meaning of 0 bar? 1. Now, if any interrupt has occurred, for example, that 7.5 or 6.5, any interrupt occurs, computer will respond. No masking. No masking. Provided, listen here, this flip flop should give you 1. If this flip flop is 0, what is that flip flop? Interrupt enable flip flop. If this flip flop is 0, what happens? AND gate input will be 0. Even second input is 1, no use. Third input is 0. All 0. So all interrupts will be disabled. All interrupts will be disabled when what happens? Interrupt enable flip flop is equal to 0. This is the hardware design. Suppose now listen here. Suppose, for example, interrupt enable flip flop is not 0, it is 1. Now mask set enable is also 1. Now see here, for example, 6.5 is 1, that is masked. 7.5 is not masked. 5.5 is masked. Then what happens? You will get these bits are coming from accumulator. Please understand that, from sim instruction. So this 1 will come, this 0 will come, then 0 and 1. What is the output? 0. 1 and 0. What is the output? 1. 1 and 0. What is the output? 1. Now 0 bar is 1. 1 bar is 0. 1 bar is 0. If it is 0, what happens? Immediately these interrupts will be disabled. AND gate na. So if it is 0, it will be disabled. If it is 1, then it will go to particular address. That is how you will design it. Okay. So this is how masking happens in the internal. Masking is with the help of AND gate. Is it clear the relation between sim instruction and this? Few more doubts will be there. I will clear that one by one. Okay. So first, up to this, clear or not? It will give you good visualization of your internal structure of 8085 interrupt. Okay. So now, what is this get RST, sir? Get the RST code means vector address. Wait. Get the vector address from external device because it is a non-vectored interrupt. What is that? See here. INTR. INTR is a non-vectored interrupt. It can be masked by whom? Interrupt enable flip flop. Because MSC is not this. This story is not applicable for INTR. So this point also clear. Now let us see. Interrupt enable flip flop. Interrupt enable flip flop will contain 2 points. Okay. 3 points. What are that? If disable input is 1, you get here 1 and automatic reset will be 1 and set will be 0. You can take a zoom inverter. It will reset. Okay, 1 minute. I'm sorry. Wait. MSC is only for vector according to sim instruction. Okay. Suppose here, if disable interrupt is 1, you will get here 1. Then it will make a reset to the system. When it resets the system, then all AND gate inputs will be 0. All interrupts will be disabled. This is one instruction. What is another way you can say? If reset in bar is equal to 0, this 0 bar will give here 1. Then 1 will give you 1 here. Again, system will be reset and all interrupts will be masked. Another case. Any interrupt is acknowledged. If any interrupt is acknowledged, what happens? If any interrupt is acknowledged, then also it will reset it. Then all interrupts will be disabled. I told all this story, yes or no? So here you can connect enable interrupt instruction. Whenever enable interrupt occurs, this will become 1 and this will become 0. Like that we can design. Our DI and EI are generally complementary to each other. Okay. Now last doubt you will be having is this one. What is that? Why this extra setup is there for 7.5, not for other people? Other people could set up 9. That is what is that? For 6.5 you see this line is directly connected. For 5.5 direct line is connected. But this fellow is having some extra setup. Why he is a special treatment इसके लिए? इनका special treatment क्या? ये तो VIP. Yes. For us it is a VIP. So technically, yes, that is the reason. Listen here. I will tell you. Here, please listen. VIP, let's take general example. Because of that only you have RST, R 7.5 bit is there to reset 7.5. Whenever it is 1, it is reset 7.5. Now see here. Because it is edge triggered, whenever this becomes 1, for example, computer is busy with other interrupts or computer interrupts are masked, whatever may be, when some edge occurs here, I will get 1 here. That 1 will be present here. Now this edge is gone. Still, this 1 will persist here. That 1 will be waiting here. Yes or no? So after the masking is completed, this 1 will be waiting here. Then the system will serve this 1. That is the advantage of edge triggering. But for level triggering, that is not the case. Suppose 1 has occurred. There is nothing to store this in this line. 1 has occurred, but after some time it has become 0. So masking time mein 1 has occurred, after that it has become 0. No use. This is like simple example. I told this is VIP, na? You came to a government office or some VIP, you ministry, somewhere you went. Okay. You are like a regular person. You went there during the lunch break. You stayed for 1 hour. And you went. But the particular concerned officer don't know you stayed here for some time. Yes or no? It don't know. It don't bother about it. I stayed 1 hour, sir. So next time, why don't you serve immediately after lunch break? By the time the lunch break is opened, you should be there. You just before 2 p.m. you feel what we call angry and you went back, or you felt frustrated and you went back. You will not be served. But this is VIP person, na? He comes. Okay, he comes. Just give. I came. Okay, he will note it. Okay, you came, na? I will note it, sir. You go, sir. So मैं तो घर चलेगा, मेरा काम तो कौन करेगा? A flip flop करेगा. So I came, I just gave the simple trigger, that's all. So this fellow will store it. He will get 1. So this fellow will sleep. He will go home and sleep. Even after lunch break, okay, lunch break के बाद immediately this will be responded. But sometimes when some critical operation is going on, or when I don't want, when that particular lunch break when the particular person don't want to respond for these ones, when he don't want to respond for this once. So before starting the lunch break, he will reset the system by using this bit. What is that? R7.5. A Pandeji. This is like our Pandeji. What is that? What is that movie? Dabang. So here it won't bother about it. So one comes, okay, it will reset it. Okay, it's itna time wait ki, itna time say one. Okay, no problem. Give one, make this 0. So this is what we call reset 7.5. Reset 7.5 ka meaning kya? Why reset 7.5 is there? Why not reset 6.5 is not there? Because it is edge trigger. So it is the system interest. If it want to serve, it will serve. If it don't want to serve that previously occurred interrupts, okay, I don't want to serve the previous interrupt, sir. Naya kaun aayega to I will serve only for them. For that case, what to do? You can reset the system. For that, you can use this R7.5. That's why R7.5 is there only for 7.5, not for other people. Not for other people. Okay. Is it clear? Other people are level triggered. Other people are level triggered. They must be stay at 1. इसका design ऐसा है. They must be stay at 1. So by the time it is unmasked, if this person is not there, there is no need to reset. Automatically system reset. But here it is not like that. No, it is edge triggered. Because of that design, if that interrupt has occurred, okay, by the time unmasking, still it will be 1. If you don't want to serve it, or if this interrupt is no more required, because iska kaam to nahi chahiye abhi, in that case, it can reset it by using R7.5. That's why for only 7.5 you have this, but not for 6.5 and 5.5. Everybody able to understand or not? Please tell. Because R7.5 is edge triggered, 6.5, 5.5 and INTR are level triggered interrupts. That is the meaning of edge and level triggered interrupts. Interrupt mein triggering ka meaning kya? If edge occurs and goes also, that interrupt will be serviced. Okay. If edge occurs and goes also, that interrupt will be serviced. So interrupt enabled flip-flop is very simple, man. See here, if any one of these conditions occurs, which I told just before, PI is executed when any interrupt is recognized when resetting bar signal is equal to 0. If any one of them has occurred, then this fellow will give 1 here. Whenever it is 1, it will reset the system. Reset का मतलब क्या है? AND गेट का one of the input, 3 inputs है ना, एक input 0 होता है, output will be 0. That is, it will not serve the interrupt. But if these things are not happened, then you will get 0 here. Enable interrupt is given, then you will get 1 here. Then you will get 1 here. That 1 will drive it. Yeah, it is not shown in the figure. You want, I can give another figure. Wait. Okay, this is also another way. EIDA. Like that, you can show multiple representations. What is your doubt? Between R7.5 acknowledge and R7.5. I didn't get you. Whenever R7.5 occurs, if system recognize that interrupt, then it will become acknowledged. That's all. When computer goes to that vector address, when interrupt is accepted, it is called interrupt acknowledged. It can be 7.5 or 6.5, anything it is same. This is another way to represent it. Okay. Here, why it is both level and edge triggered. Why it is both level and edge triggered, I told you now. to avoid unnecessary response to the noise, to avoid unnecessary response to the interrupts. So that is about your, what is that, sim. Okay, you got the clarity, hardware clarity, right? I still love this subject even they remove from the exam. So let us see. This is more logical. See what you have studied in your flip-flops, everything comes here. Thank you, Aditya. Okay, you are asking this. RST is acknowledged, you will get here clear to clear this. Okay. To reset it once it is acknowledged. Okay, see here, this is both positive and level triggering, and this one is positive edge triggering. Okay, shall we move? Right, shall we move? Thank you, Ruchita. Now, let me write those points. Trap is both level and edge triggered. To, that is, edge should occur and stay for some minimum time. What is that minimum time? You can say is minimum time is generally you can say the propagation delay of this gate. What we call propagation delay of this flip flop. It requires some time to get this now. So during that propagation delay of the flip flop, it should stay for one. Then we will assume it is a valid trap. Thank you, Aditya. So, but one thing is wrong. If nothing happens in life, you want to teach. That is wrong. Teach it with passion, not as a last option. Most of the teachers you see in this platform, okay, are by choice, not by virtue or something. Okay. Yes, Shivam. So what Shivam said is correct. It is not, I mean, everybody can have that ability, can do it, but it's not that easy to convince the crowd. Yes, I know he meant in good way only because I know he loves me very much. I just, whenever situation comes, we need to, I'm just kidding. That's all. I don't have any regrets. I'm just kidding. That's all. Okay. So trap is both level and edge triggered. That is, edge should occur and stay for some minimum time. Okay. Stay for some minimum time to avoid unnecessary. Good, Aditya. To avoid unnecessary. Me too. To avoid unnecessary response to trap for noise like impulses. Okay, to avoid unnecessary responses. Unnecessary responses for noise like impulses. Okay, so is it clear? Trap is both level triggered, that is, sorry, why that is, and edge should occur and stay for some minimum time to avoid unnecessary responses. Since trap is used in critical applications. Critical applications like power failure. After one trap recognized, then it should become zero and edge should occur. Then only next trap can recognized. That is the meaning. Okay. So second trap can be recognized only first interrupt should complete. That is, it should become zero and next again 0 to 1 should happen. Another line is RST 7.5 is edge triggered interrupt. That is, when RST 7.5 becomes 1 from 0, okay, even it is again becomes 0. Even again it becomes 0, interrupt request is saved in flip-flop. If CPU or 8085 you can say don't want to serve this previous request during mask or another ISR, 1 minute. Then R 7.5 is equal to 0 in sim to reset previous occurred RST 7.5 requests. These are the points. Okay, so my writing is not good here, don't worry. I'll read. RST 7.5 is a edge triggered interrupt. That is, when RST 7.5 becomes 1 from 0, even it is again becomes 0, interrupt request is saved in flip-flop. If CPU don't want to serve this previous request, okay, let me write properly. Previous request. Okay, during mask, then R 7.5 must be equal to 1 in sim instruction to reset the previous occurred RST 7.5 requests. Is it clear? Good. So let's move to the next. Good. Now, the next instruction is RIM. The last instruction, in fact. Read interrupt mask. After RIM instruction, based on accumulator contents, we can see serial input data and interrupt status. It is just to read, not to set or reset. It is just to read. Let me show you. Like sim instruction, rim instruction can also be used. These are the points. First point will tell you serial input data. What is the available data in the serial input data? So which interrupts are pending? That is, the interrupt is waiting. System is not responding. This is called pending interrupt. Okay. We call interrupt latency. Interrupt latency. It is time between actual occurrence of interrupt and its service. Okay. Generally, interrupt latency must be as low as possible. Interrupt latency must be as minimum as possible. Okay, it should be as low as possible because system should respond to the interrupts as fast as possible. So, okay, leave it. Now come here. SID. What is the meaning of SID? Serial input data coming from the SID line. Next, these two will tell you whether the particular interrupt is pending. Latency, that is the meaning I have given here. Aditya. The time gap between the response and its occurrence. You ask me doubt. Okay. I respond while I'm doing the explanation. I don't respond. After that, I respond. I will explain you. The gap between them is called as latency. So it is the time between actual occurrence of the interrupt and its service. So 7.5, 6.5, 5.5 are called pending interrupts. If they are one, computer that interrupt has occurred but not serviced. Okay, if this bit is 1, 6.5 will status and 5.5. This will tell you status of interrupt enabled flip-flop, whether interrupt enabled or disabled. This will tell you which interrupt is masked or unmasked. This will tell you which interrupt is masked or unmasked. Is it clear? Okay. For example, let's take one example. It will make clear. Okay. After rim instruction, if accumulator is copied with BA hexadecimal. BA hexadecimal. What is the problem? Okay, BA hexadecimal. Determine status of interrupts. Okay, let's do it. Let's crack it. So B means 1011. A means 1010. Now this is SID. Okay, this is 7.5, 6.5, 5.5, interrupt enable, M7.5, M6.5, M5.5. So here IE is equal to 1. So what is this meaning? RST 6.5 and RST 5.5 are in which state? Pending. What is the meaning of pending? They have occurred but system not responded. But in that already RST 6.5 is masked. These are unmasked. I am writing not masked for easy understanding. We write it generally as unmasked. You understand now the meaning of rim instruction? In fact, your all instruction set is completed. Finally, we did completion of all instructions. Yes, ho gaya. Total job is done. It is not having hardware, Aditya. Why it will have hardware? Okay, simple. Please listen. It will read that bits from these lines. From these lines, it will read the bits and give it to the accumulator. It is reading it. It is just reading the status. It reads from mask of 7.5, 6.5 and all. Okay? Thank you. So let's move. Let's move. Let's halt. Now, let's see some programming. Tomorrow we discuss IO interfacing. So programming is very good, Asif. In that, first we are going to discuss delay programs. Get ready with your poll button. We are having exciting results waiting for you. It is a port is IO address name, we call it as port. IO input output bus is there, na, iska address we call it as port. Right, let's start the polls. Delay programs. Let me start with one question. 1 minute, where is that? I don't have print, I think. Ask Mark. You can ask out of the galaxy. Actually, Mark, no one knows it. Generally, it depends on the year. 4 to 6 you will get. And that is analog plus digital, you may get 8 to 12 marks. It purely depends on examiner mode. Sometimes in the whole subject, he may give 2 marks from analog. No one knows. It depends on that particular year examiner. At least to today, if they made the paper as 150 marks, I could be more happy. It is just like astrology. I say this year you get 6 marks from analog electronics, for example. Okay. If it hits, I will record this, I will show to the next one. That I said on that particular day, it happened. If it doesn't hit, I will stay silent. Shivam, I have answered this with one special class to remove those misconceptions. We cannot say that, okay, that what we call IIT gives, Bombay gives, all IITs are good. Even, okay, giving tough paper, if it is their job, anyone, in fact, not only IIT, you give it to local university, they can also give tough paper if that is their intention. They don't give you tough paper, that is not their intention. It depends on the examiner mode. He wants to test your skills, he will test. So it don't analyze those things like previous 2013 they have given, all those stuff won't work. The panel will not be same or the process may not be same. Don't never take that. Okay. Yeah, that is good. So let's see the program what I want to give. Where is that? Delay programs, right? Right. So let's start the program. Determine why what happened. Yeah. That is correct, Surya. What I want to say is a delay program. Okay. Determine, please listen carefully. Listen here. Determine the number of times Yes, Aditya. Even in my special class also, I told the same thing. It's a panel. Every year it changes, and also you don't know who. Some different IITs say different people will give that. It's a whole panel. So this is organizing only. Okay, so I will give you now few programs. Okay, initially zero flag is equal to zero. You assume zero flag is equal to zero. So I will give you a few programs. Let's start first. LXI. Don't comment. I will conduct the poll. Double F, double F, hexadecimal. Then L means loop. This is generally actually address. Okay, decrement H. Jump if no zero to loop one. Jump if no zero to loop one. So tell me how many times it will happen. 255, 256. I will start the poll. Get ready. Question is clear or not? Please tell me. If it is not clear, I will explain. Determine the number of times delay programs we are discussing. For that, I am giving you the base. Determine the number of times the following program is executed, assuming initially zero flag is 0. Now this instruction, jump if no 0 to L1. How many times this happens? So are you ready? Shall I start the poll? Double F means 64K, 64K. Okay. Start the poll. Okay. Try. Only 3. I think Asif and 2 more have given right answer. Otherwise, the remaining all wrong answer. So, what is the right answer is here. Infinite. Okay, because DCX does not affect flag. Okay, DCX, if it is a DCR, it will affect, not DCX. Is it okay? Shall we go to the next question? Same statement is same. Okay, initially zero flag is 0. All for all questions it is same. Okay, next. Okay, so now please read that. I will start number of times. What is the right answer? Let us see. Okay, please see. Same options I am giving. Ready? So you made it. Some 50% gave right answer. Good. Very good. What happened, Aditya? So these are the top 10. Yes. Here, your zero flag will be equal to 1 because of XRA. Okay. So after this, decrement H happens and it will come out. And it will come out because jump on here, no flag affected. No flag affected. Affected means what? It will stay in the previous value. No flag affected. Flags are not affected, but already it is at 1. So these are no flag affected. It's zero flag is if no zero, go there. But it is 0 now, it will come out. Only one time. Not z equal to 0 always. Z is initially 0. This instruction will make z flag equal to 1. Then these flags, these two instructions will not modify the flag. They will keep previous value. They will keep previous value. XOR A with A, accumulator will become 0 now. Because of this, 0 flag will become 1. So what is the right answer here? One time. Next, let's take one more. Let's take one more. Okay. So now let's remove this DCX job. Let's go with DCR only. Let's take a loop like this. MVI C comma FF hexadecimal. What is the meaning of F? Sorry. What is the meaning of FF? 255 in the decimal. D means decimal. Okay. Then DCR. I'm not saying DCX now. What is that? DCR C. Jump on no zero to L1 and hard. DCR, okay, I don't specify. You understand the difference. DCX is different, DCR is different. Okay, DCR may flags will affect. DCR will affect the flags. All flags except carry will affect. I hope you remember it. I just recollecting. Now, how many times? Initially, zero flag is 0 only. So, number of times. Let's start the poll. Okay, start the poll. So again trapped, only 18% right answer here. Very less number of right answers. What happened? You people are there or not? No comments are coming. What is the right answer here? Infinite. Here DCR will make this 255 to 254. But where I am jumping, carry here flags are affected. But where I am jumping? Again to this location. This is the address. I name address ka name. I write it as L1. Originally here you write the address. Okay. This is what we call labeling. Okay. Now again it is loaded with FF means again 255. It's a continuous process. How many times it will do? Infinite. You should not keep this L1 here. You should keep it in the bottom. We decrease and load it, decrease and load it. This is the common mistake will be done in your programming. That's why we have taken this exam. Done? Okay, maza aaya? Let's move. Lastly, MVI, this is initial. C comma 00. Yeah, it will state only when zero flag will become, only when it becomes 0, it can change it, but it is never becoming 0. It is never becoming 0 because 255 decrements, it increments. Decrement and again load it. Okay, tell me number of times. I will start the poll. Shall I start the poll? Jump if no 0. If there is no 0, if 0 flag is not 0, okay, if 0 flag is this one, it will go back. If 0 equal to 1, it will come out. Shall I start the poll? Right. Let's start. I'm sorry. The poll. Good. So these are the right answers. So Asif, finally you made 4 out of 4 today. Very nice. So here also some people gave wrong answers. Okay, see, now you understand. If I decrement, this will become 255. Is it equal to 0? No. Go back. Here now it is going to here only. 254. No. Then what happens? So every time it come back, please listen how it is doing program. Okay. Decrement. Okay. Not 0, go back. Decrement. Not 0, go back. Next. Decrement. Not 0, go back. Like that up to 1. 1 is equal to 0? No. Go back. 0 equal to 0, come out. So how many times it has repeated? 255 to 0. How many times? 256 times. Please understand, if you decrement 0, 0, what is the answer you get is FF, that is 255. I told last lecture. Yes or no? If 0, 0 is decremented, you get 255. Because of this 0, 0, you don't get 0 flag equal to 1. Okay, be careful. That's why I gave both the options, 255 and 256. Suppose same question, MVI A comma FF, decrement A, jump if no 0 to L1. In this case, it is 255. Okay, because so you should check if you have doubt, take some small number like 10 or 5. Then decrement it, check it, how many times it is doing. Proportionally, you give your answer. So here it will decrement means 254, 253 and so on, 1, 0. Anuj, DCX is not having any relationship with flag. No flag is affected by DCX. DCR will affect the flag. Okay. After DCR, if your answer is equal to 0, then 0 flag will be 1. So decrement will affect the flag. Affect does not means it makes 0. It will affect according to the result. Result is 254, 253. Whenever it becomes 0, then 0 flag will be 1. So now, while calculating the delay, the formula is like this. Total delay is, now we see the delay programs. Total delay is equal to TE plus TD, sorry, TI plus correction. Okay, plus, or actually it is minus only, plus in the sense it may be negative value, that is the meaning. So correction. So let's take one delay program. In 8085 microprocessor, following program is executed on 2 megahertz clock. Determine total time required for execution. Determine the total time required for your execution. How much time is required for the execution is the question. So let's see that question. MVI A comma FF. Decrement A. Jump on no 0 to L1. Halt. This is your L1. Okay. Examiner has given T states also. If you remember, okay. Don't remember also, no problem. Okay. Anyway, you don't have the examiner right now. You need not worry also. 4T or 5T. So this is the program given. What is the question is to calculate how much delay is created by this program. How much delay is created by this program. Let us see. So are you ready? Right. No poll, I will do it. It's a mathematical part. So here we start with 255. It is same as previous, just calculation part is left. 254, not 0 na, go back. 253 and so on, 1. After 1 it becomes a 0 and come out and halt. This is what happens, right? Okay. What is the external part is these two. It is not in the loop now. Outside the loop, what is time? 70 plus 5t. What is the internal part? Internal you have, forget about 7 and 10, write like this, 10 plus 4. Into, how many times it is running? So we can write like this. Good. So this is running for 255 times. So 70 plus, sorry, what is that? Internal is 40 plus 10t into 255. What is the correction? We will see. Because see here, every time this condition no 0 jump, no 0 jump, no 0 jump, like that condition satisfied 10t states. Last time condition not satisfied. It is not jump if no 0, but it is 0 na. So it come out. Condition not satisfied. It takes only 70 states, but you calculated as 10t states. So take minus 3t. What is the correction you should add is minus 3t for the last jump. So what is the answer? Total delay is equal to, it is I think 12. Yes, 12t plus 14t into 255 minus 3t. Here t is equal to 1 by 2 megahertz is given by examiner, that is 0.5 microsecond. So what is the answer you got? What is the total delay you got it? 1.78, right, Asif, correct. 1.78 milliseconds. Good. You understand how to calculate. So this program will generate a delay of this much gap, 1.7. Similarly, you can introduce NOPs in between to generate the delay. Okay. So because you need, suppose, this kind of output, 1 for some time, 0 for some time. So first you give 1 in the output, you create delay, and again you give 0, and again you create delay. Like that, required clock can be generated using this program. Using your CPU clock, we can generate. What is one more? What is your doubt, Aditya? Using your CPU clock, you can create this kind of delay programs where you can use the output port, okay, to give ones and zeros for this much amount of time, 1, this much amount of 0, like that we can do it. You into one more portion. Okay, don't worry. We'll discuss one more, no problem. So is it clear? Generally, one more thing I want to say, the clock we apply to the system may not reach to all devices with uniform delay. Some systems will have little delay. This is what we call clock skew. Okay. So that delays should be taken care by the what we call designer, such that those delays will not affect your system performance. Okay. Here what I want to say, this is a delay program. Application is your wish. One event and another event ka beech mein you want to create some delay, you can use it. So here, why to use? You can do multiple loops also. What is that multiple loop? Loop inside another loop. Let us take that example. Nested loop. Nested loop ka meaning is XOR A with A. MVI. Let me take some example. Okay. Will you try? Handshake ka meaning is in communication, when you transfer the data, system will send acknowledge. Okay. Or whenever its system requires the data, it will send request. Tomorrow when the IO interfacing, we discussed that. Then computer will send the data. I am free, I am ready, please send the data. It will send that. Then system in response will send the data. After receiving the data, the other end device will send acknowledgement. This is called handshaking protocol. Okay, calculate this if you can do it, or shall I do it? Okay, listen. Okay, I'll wait. So please listen here. It is a loop inside another loop. This is one loop, and this is another loop, loop 2. Okay, so now this part is external, and this part is also external. I gave the T states 40, 70, 70, 40, 10 by 7, 40, 10 by 7, 5T. Okay, so these are the things. So now what is the total delay? Is total delay equal to T external? External kitna? 40 plus 70 plus 5T. This is external. Now we should calculate internal. Be careful now. Be careful now. To calculate this internal part, from here to here, from here to here. Okay. So what is that? Not infinite loop. It's not infinite loop. Okay. Listen here. Listen here. How it is doing? It will here first 20 is there. Okay. Here it is FF. Then 1 minute, please. Otherwise, just wait. I will take a screenshot so that I can erase that and why it is not coming. Okay. How many times it is doing this job? Here it is 255. This will become 254. Not 0 na 253 and so on 1 and 0. After 0 it comes here. After coming here it decrements. Where is that decrement B? I forgot to write that. I'm sorry for that. Yeah, decrement B is there. No, sorry. Decrement C is there. So here what happens? Nothing wrong. Nothing wrong. Decrement C. C means what? This is 20. 20 ka matlab kya? 32 in the decimal. Very good. So it will become 31. Is 31 equal to 0? Is 31 equal to 0? No, it is not 0. Go back. So go back. Go back to where? This position. Then now again start. Move immediately. Be with 255. So I will start from 255 and again it will become 254, 253 and so on 1 comma 0. Now after 0 again same story. After 0 what happens? 32 will become 30. So and so on. This story will be continued. Okay, this will be continued until this becomes 0. So 1 and 0. So this will happen for 32 times. And this will happen 256 times. For 250. So totally is this 255 into 30 so that you can give more delay. 31 to 0 man people 0 is to be considered. Once 0 it come out. Once it is 0 it will come out. So now let's do the calculation. So internal of internal will take how much time? 40 plus 10t. Internal of internal, that is loop 1 takes 40 plus 10t. This is loop 1 into how many times? 255 minus its correction. What is its correction? 3t. Now this plus extra is what? Extra is 70 and the last one 10t. Alt is external mein covered already. This will make loop 2. This will be done how many times? 32 times. Failed one time, so minus 3t. Failed one time, so what is that? Minus 3t. I will repeat, don't worry. What is there? Decrement C, 40 is also there. Don't worry, I'll write. Space is not enough, so I'll write in the next space. The total delay here will be 40 plus 70 plus 5t. This is the tx plus, what is that? 70 plus this one, internal part is 40 plus 10t into 255 minus 3t. Correction, okay, plus external again 40 plus 10t into 32 minus 3t. This is loop 2 correction. This is loop 1 correction. This is loop 1. You can also write like this. You can also write like this instead of doing this much. It is t external plus this is 70 plus this is 4t plus 10t into 255 plus 4t plus 10t into 32 minus you take correction 32 times. Sorry. Loop fails how many times? Loop fails 32 times. So that 3 into 32t minus 3t. This is for both will give you same answer. This is for L1, L2. This is also give you same answer. Okay, this is called loop in a loop. Nested loop concept. Okay. So this is how you calculate the delays. I mean, you can generate the delay programs. Next, write a program to add 5 consecutive numbers whose starting address is 2000 comma 2000 comma next 2000 contains n consecutive numbers. 2000 contains n and 2001 to 2000n onwards data and store result in next 2 locations after data. Is it clear what I am saying? You need to write a program that add n consecutive numbers. Suppose for example, see, in 2000 you have some number 5. So 5 consecutive numbers are there up to 2005. You should add them. You should add them and store the results in 2006 and 7. Question is clear? Shall we do it? Question is clear to you? Yes or no? Right. So firstly, please listen. What to do? LXI HL register pair with 2000. Okay. I have not 2000 times. You need to run the program from 2000. Here you have some number. It can be any number. That many number of times you should add. That many next content of 2000 is some count. It can be x, n, 2, 5, any number. So next 5 numbers to be added and saved. That is the meaning of the question. You have 5 here. Next 5 numbers are to be read, added and stored in the next 2 locations. Okay. So first I load the data. Load the address. Then move C comma M. Then C will get count. C will get the count. Then what to do? Increment H, that is move to the next location. Now you have data. Now you are having data. 1 minute. First, clear the accumulator, XOR A with A, then INX H, that is move to the next location. Move to the next location. Add that location to the accumulator. Add that location to the accumulator. Okay. Then, after addition, 1 minute, move B comma A. I will tell you the meaning of that. Okay. So let me write in a proper way. Space will be covered properly. After that, what I want to do, XOR, then XOR A with A, move B comma A. That is, I am initially making them to 0. Then increment H. Increment H. After that, add M. That is the new value, that is accumulator is added with A plus the content of M. Initially, what is accumulator? 0, 0. Not decrement C. Here, after addition, you should check carry. Jump if you have carry to L2. Okay, otherwise, wait. Jump if no carry to L2. In L2, okay, in between, if it is carry, you need to increment B. I will tell you the meaning of that, just wait. Then, in the loop 2, what you need to do, as you said, decrement count. Jump if not 0 to loop 1. What is loop 1 is this. After that, after this process is completed, your result is there in B and A. Result is there in B and A. So to store the result, what to do is, again, increment H, move. First you can store A. Yes. Then increment H, move B comma A. Sorry, B, M comma B. No, I will explain it now. Just wait. So here, lower byte. Here one important point is there, lower byte of result. Here, higher byte of result. Lower byte of the result and higher byte of the result. So now I will explain you. First, let's take one physical process. For example, count is equal to 5 and your number is 79, 30, 49, 89, 98. Let us randomly take it. Okay, these are the 5 numbers you want to add it. So what is the answer, sir? 9 plus 9, 9 plus 9, 9 plus 9, 8. What is the answer? Please tell me. Okay, you take decimal only for easy understanding. For understanding easily, okay, decimal you take. 9 plus 9 plus 9, 27 plus 8 is how much here? 27 plus 8, 5. And 3 will come. 10, 13, 17. 17 plus 8, 25. 25 plus 9, 36. Sorry, 34. Now you can do this operation like this also. 9 and 79 and 30. You add it. What will you get? 9. 7 plus 3 is what? 109. Okay, then what to do is, please listen. Add 49. What do you get? 49. Okay, keep this one as it is. Now add 89. What will you get? 8. You will get 1. 5 plus 8 is how much? 13. you get 1. Don't forget about the carry. Forget about the carry. Any problem? 109. Yeah, 58. Na? One minute. 1 minute. Forget about the carry. 58. Okay. Then add 89. What will you get? 9 plus 8 is 7. This will come 1, 14, and 1. Forget about carry again. Then 47 ko you add 98. 7 plus 8 is 5. 1 will come. Then 1 plus 4 is how much? 5. 5 plus 9, 14. Forget about this carry. So now 1 plus 1 plus 1. What is the answer? 3. So answer is 345. These 3 ones are to be added. Whatever you get is 345. That is the same result. So this is what I have done here. What is that? I have added. If carry comes, I am adding it to the B register. If carry comes, I am adding it to the B register. See here, that is what it is doing. Increment H, add it. If no carry is not there, go to decrement C directly. If carry is there, increment B. That is, it will increment B value to 0 to 1. Okay, like this, where every time carry comes, it will increment the B value. Here it becomes 1, 2, 3, like that. So after that, what it is doing? Decrement the count. Is it 0? No, go back. Is it 0? Same story. Lastly, once it is 0, then increment it. Next location may store the A. Next location may store the B, which is having your higher and lower byte of the result. Now homework. Repeat this program to multiply two numbers at 2000 and 2001. Not repeat, modify. This we discuss tomorrow. Modify this program to implement multiplication. Why jump on no zero loop 1? Otherwise, how you first addition is completed, okay, decremented. How to do the next? We should count, keep on adding this now. After first byte, second byte is to be read, third byte is to be read. For that, increment it, add it. Not 0, increment, add it. This will store carry. Why loop 2, man? You should, every time you should move your pointer, Abhinay. You should move your pointer, then only it is valid. Please listen here. Jump on no carry. I'm sorry, I have not written that. Okay. Is it clear now? Good. So you try this homework part. Thank you. So that's all for today. We can meet tomorrow. Or 9:45, you can attend the special class so that we can discuss the things about our new notification. Tomorrow we will finish the interfacing, SRAM, DRAM, all the story we will be discussing. Good night. Good night. Homework tomorrow, first class, starting we discuss this. Bye bye. Good night.